Welcome back, everyone. Sit down, get comfy. We're going to do our last round of talks, starting off with some functional programming in Kotlin, and we're going to explore some arrows, or arrow, it's just a singular arrow, with Ties van de Ven. He's asked me to save the questions for last, so we'll get to those at the end. Enjoy, have fun.
Thank you very much. Yeah, good afternoon, everyone, and welcome to my talk about functional programming in Arrow, or in Kotlin using the Arrow framework. So first, a little bit about me. My name is Ties van de Ven, and I'm a software engineer working for a company called JDriven. And I've been doing professional software engineering for about 13 years or so, and I'm actually quite proud to call myself a software engineer, because I'm really passionate about the engineering part of software engineering. And with that, I mean, I love the higher level concepts, higher level abstractions, general reasoning about code, and just the whole problem solving aspect of it. And because I'm very passionate about this topic, I love to talk about it. So you guys may think that I'm here as a service towards you, but instead, you're providing me a service because I just get to talk about my favorite subject for 40 minutes, and it's kind of rude to interrupt. So on that note, my friends and family and such would like to thank you for finally getting a break from all this. So I wasn't always an engineer. In the beginning of my career, I was working on this big monolithic application. And with a big monolithic application, you have to think about something that's 10 years old, over 1 million lines of code, currently about 1.5 million lines of code, and still gets features added every day. And most of the time I was working on this, I was working on solving and creating new bugs. And when you start fixing bugs for quite some time, you slowly start to get a certain hate against these kind of bugs. And you see certain patterns, as in, hey, this bug is basically the same thing I solved last week, just a slightly different context. So I try to find ways to how can I reduce the amount of bugs in my code? How can I change my software coding style to make sure that these bugs won't happen anymore? So I started doing this, and slowly, over time, I rediscovered a few things like immutability and such. Back then, I didn't know that was an actual thing. I just tried different stuff, and some stuff worked, some stuff didn't. So when years later, when I finally started reading into functional programming, I realized I could have saved myself for like 3 years of time by just reading up to this, because I discovered basically the same stuff. So it's important to note, I came to functional programming not from an academic point of view, because it's a very academic subject. So I'm not great at the math aspect of it, although I'm still learning that, and it's actually quite interesting. I come to functional programming from a solution point of view. I needed a solution for my problems, and functional programming was giving the solution to me. So if there's anything after this talk you want to remember, try to look into functional programming. It will definitely make you a better programmer. So what will we talk about today? We're going to do a little bit of functional programming theory. We're going to talk about monads, specifically the item monad, how it would look like if you use it in a real-world application, and we're going to finish with some optics. If you now think, hey, that kind of looks familiar because we had the same topic earlier this morning. Yeah, there will be some overlap. Just use this as an opportunity to boast to the person next to you on how good you know this stuff already. Okay? So let's talk about functional programming. And to start with, let's ask the question, what exactly is functional programming? And this is a very difficult question to answer. There are some official definitions, but every functional program we ask will give you a slightly different answer. So my answer to this question, functional programming is a story about love. It's about loving your compiler. Because as a functional programmer, we try to make as many runtime exceptions and turn them into compile time exceptions. So once the code actually compiles, you're basically guaranteed to know that stuff will just work. So that also means you have to write a lot less tests, because your compiler already makes sure these things can never go wrong anyway. It's about loving your team members by writing explicit code. For example, if you use the immutability pattern, state changes suddenly become really explicit. You instantly know a state change has happened, instead of some setter way down the function scope that's ruining your day. It's about loving your cake, and a bit more about that later. And of course, about loving your functions, because it's functional programming. So let's talk about functions. And specifically, let's talk about function signatures, because this is actually arguably one of the more important things of a function. So what is a function signature? A signature is derived from the input and the output of a function. So if you take a function foo here, it takes a string and produces an int, which means its function signature is given a string, produce an int. Or if we abstract it even more, basically given an A, produce a B. And if you now think, yeah, that's basically true for any function, that is true until we need to do something with error handling. Because suddenly, if your function can go wrong, it has an extra return type. It either returns the correct thing, or something else needs to happen. It needs to return an error state. So what is in that sense an error? We reach an invalid state. We now need to short circuit. We need to stop executing code from now on until we either manage to recover or we crash the current program or thread. So how does Kotlin solve this issue? Kotlin has runtime exceptions, and we have the nullability system. So let's take a bit of a look how those things work. We have here a divide function that takes two doubles and produces a double. So the signature is given to doubles, produce a double. Since the second operator cannot be 0, we do some checks for that, and we throw, in this case, a runtime exception. When I said the function signature is given to doubles, produce a double, this is actually a lie. What the function actually does is, given to doubles, I might produce a double, or I kill your current thread. Which, if you think about it in that way, is actually quite a horrible thing to do. And the worst part is, the only way for you to know this as a developer is by reading the bit of documentation I added on top of the function. Now, I'm sure all of you read the documentation of any function used before actually using it. But I'm sure you have some team member somewhere that doesn't always read all the documentation, if there's documentation at all, because in a lot of cases, this is not documented at all, and this is hopefully catched by your tests, or else this is a nasty runtime surprise. So runtime exceptions are actually quite a nasty thing, but they do have one advantage. Once something actually goes wrong, we know exactly where it went wrong and what went wrong. Since we get a nice stack trace, and it also has a nice message that we couldn't divide by 0. So if it went wrong, we actually at least know why it went wrong. If you now compare this to the Kotlin's nullability system, suddenly the function is also a lot shorter. But now the signature is given to doubles, produce a double question mark. And this is where Kotlin's nullability system comes in. Because null in Kotlin means something very different than null in Java. Because in Java, it's basically an any type. Whilst in Kotlin, something being nullable is there in the type system. And the question mark says it might return something that is nullable. And this is a very, very powerful thing, because Kotlin will not let you operate on a nullable value. So instead, we need to use operators like operator, which says if the previous value was non-null, then execute this function on it. And we can keep on chaining the happy path until we finally reach the point where, hey, if anything went wrong previously, we use the else operator and just use this default value instead. And this is a good thing, because we can now keep thinking in the happy flow and only need to deal with the exception all the way at the end. But it does have a bit of a problem. Something went wrong now, but we don't know why. So on one side, we have runtime exceptions, which we don't know, they can occur, but when they do occur, at least we know what happened. And on the other side, we have the nullability system, where we do know something can go wrong, we just don't know what goes wrong. And I want both. I want to have my cake and eat it too. I want both error context, and I want error as a return type. And because I had this problem, I did some Googling, and that's where I finally found the error framework. So what is the arrow framework? It's a functional programming library for Kotlin, where the good news is it's on the heavy development, so they're continuously adding more features, improving stuff. The bad news is it's under heavy development. As in the 1.0 release was September this year, that's only a few days ago. And because everything is under heavy development, the changes they make are arguably good, but code samples from January don't compile anymore. And there have been places in the documentation that says // to do. So actually coming up with some examples here, that took a lot more effort than I previously expected. But I imagine now there's a 1.0 release, things will stabilize a bit more in the future. And the stuff that's there is still production ready. So what does Arrow offer us? It has some monads, it has a few improvements to coroutines, some objects, and some meta-programming where you're actually writing compiler plugins. So today we only have time for some monads and some optics. I really wanted to include some meta-programming, but after finally getting it working after a few hours, then I read that they're completely revamping it and it's going to be released next month. So maybe that's a talk for next time. So let's talk about monads, and specifically the IDA monad. And when I mention monads, that a lot of people find that's a scary word. But it really depends if you come from a problem solution perspective and first an academic perspective. Because you have the monad paradox, when you truly understand a monad, you can no longer explain it. But you guys are luck, because I actually don't know what a monad is, and therefore I can explain it to you. So a monad is very different from the Mavi stuff and from the problem solution side. So from a problem solution side, a monad is nothing more than a wrapper you put around the return value. Because a function cannot right now return a correct thing or cannot return the correct thing at all, but you still want to return something. An example for that, we just saw in a previous talk that mentioned the future, that's also a monad. It cannot return a function now, a value now, so instead I'll return a wrapper that takes care of that stuff. So a monad, it's just a wrapper around the return value, and that's it. So let's talk about the IDA monad. The IDA monad has two generics. There's a generic on the left side and a generic on the right side. Where the generic on the left side contains the type of the error context, the stuff we missed with the nullability system. And on the right side, it's a generic of the actual type you're interested in. Where the convention is the right type is right. This right is right, that's the happy flow. If you're now thinking, what is this for kind of weird naming convention? You're not alone in this, but to be fair, it's kind of hard to find a naming convention that works in all scenarios. So they picked this is default, we just have to live with it. So you have the left and right is right. It's also important to see how the IDA is actually implemented, because it's using a sealed class, which means it has only two possible implementations. It's either an instance of left or an instance of right. Therefore, it can never be both. So while the IDA has two generics, you never actually get an IDA object. You get an instance of right or an instance of left. So if we now look at our divide function, if you would rewrite it using an IDA, we will see that the function signature is now given two doubles. I either return an instance of left containing a string that says what went wrong, or I return an instance of right containing the actual double we're interested in. And we can just create this instance like this. Or if we're a bit more lazy, and since Kotlin has extension functions, we can just call .left or .right on it, because they made extension functions for everything here. Or if we want to be even more lazy, we can just replace this whole thing with the IDA.catch, which just catches any exception that gets thrown and turns it into an instance of IDA.left. If we now think, oh, that throwable on the left, I want to actually go back to our string, oh, that's perfectly possible, because we can just call a mapleft function, where we transform the left side into whatever we say it needs to be transformed in. In this case, we can just supply the string again, turning our function signature again into given two doubles, return a string with either a left containing a string or a right containing a double. If we can map the left side, we can also, of course, map the right side, where we can turn, in this case, our double into a string. It's important here to know that the map left only gets executed, the function you supply it with only gets executed if it's an actual instance of ida.left. Otherwise, this operation just gets ignored. Same with the map. It only gets executed if it's an instance of ida.right. So this is where your happy flow goes. This way, if anything went wrong within your entire chain, you don't have to worry, the rest of the code won't get executed, won't waste any CPU cycles. So now we have an either, but you can't actually use an either in stuff. At some point, you actually need to go back to a value. So what does that look like? Don't worry, we're gonna go from the top to bottom here. First, we're gonna get our either from our divide. So although the type is either string double, it's actually an instance of either an instance of right containing a double or an instance of left containing a string. One strategy is to completely ignore the left side and just call or null, which means if it was an instance of right, you would just get the double. Otherwise, if it was an instance of left, you get null. Or else is another thing, if it's an instance of left, just give this default value, or if it was an instance of right, give me the correct value back. But this is actually not a really good use case for an either, since we have the error context for a reason. So let's see how we would use that. And because it's a sealed class, we can pattern match over it. And because it has only two instances, this when covers all of those cases. So we can first check if it's an instance of either.left, in which case the Kotlin compiler is nice enough to automatically cast my either to an instance of either.left. So my either.value is in this case of type string. Otherwise, we can check if it's an instance of either.right. Again, the Kotlin compiler casts my either here to an instance of either.right, which means that my either.value is now an instance of double. So we can do things like ×2 on it here. And lastly, we have a get or handle, which tries to transform the left value into the type of the right. So try to recover from being a left. In this case, we have a string, so it's going to be quite hard to return to change that into a correct double. So in this case, I can just use it to log an error and return 0. And the nice thing about either is they compose really nicely, in a way that you're actually quite already familiar with. Because if you think back at our Kotlin nullability system, it's actually very similar. So we have our divide function, which returns an either, or at the bottom, using the nullability system. We can now continue on doing the happy flow on it. In this case, I use a flat map because the map operation actually wraps the result into a new either, and that would mean we would get an instance of right containing an instance of right containing 2. The only difference is with flat map, it doesn't do the additional wrapping. So the short is, if your function returns an either, use flat map, otherwise use map. And in the end, we're going back to a value. So if you can use the Kotlin nullability system, now you can also use monads. It's that simple. Monads are actually not that hard from the problem-solving perspective. Also, if we're seeing this code, we're now completely ignoring the left side. And if we're doing that, I would also suggest don't use an either here. If you don't do anything with the error context anyway, just use the inbuilt Kotlin nullability system. Because I don't want to give you a tool now, get you all excited, to transform all your codes using eithers, and just not using them. That would be a bit of a waste. So now we know what an either is. Let's see how this would work in a real-life application. So I made a bit of a pseudo Spring Boot-ish application. It's just for the example. And we're going to start with a very naive implementation and slowly see how eithers would improve this. So we can start by defining a few repositories where to get data. In this case, we have a repository that can get a speaker, a repository that can get a conference, and a repository where you can store a booking, which is booking a speaker for a conference. Very simple, you don't have to think too much about it. And that one will return a long, which is the booking ID. So our service would look something like this. First we get a speaker, then we get a conference from the conference repository, we create a booking, and we store the booking. And we need a controller which gets the booking from the service and just return HTTP 200. Why is this a naive application? A lot of stuff can go wrong here. What if a speaker isn't found? What if a conference isn't found? What if my database connection dropped? What if a web service isn't available? A lot of stuff can go wrong here, and yet this perfectly compiles. One thing we could do to mitigate that a bit is, of course, just put a try-catch on it. And we have to make sure our repositories throw a not found exception in case something is not found. Otherwise, we have catch just a general throwable and solve it that way. But I kind of don't really like this approach, and I'm going to show you why. So, how can IDERs help us improve upon this? Well, before we start dealing with the right stuff, let's first create the left value of IDER. And I would suggest using a sealed class for this. So we can define a class bad state and give it two members in this case. Either something is not found, or something is a bad state with exception. And it can only be one of those two in this case. So now we have our left value. We now need to do some magic and rewrite all repositories that now return IDERs containing a left value of bad state, which is either not found, or a bad state with exception that saves the exception. And on the right side, whatever it was returning in the first place. I'm going to skip the service for a minute and go straight to the control. This is a lot of code. So let's go through it slowly. First, we're going to create a booking. So out of the service, we get an IDER that's either an instance of left containing a bad state, or an instance of right containing a long, containing the booking ID. Because it's IDER is a sealed class, we pattern match over it. If everything went correctly and it's an instance of IDER.right, we can just do the old behavior, return a HTTP 200 OK. If, however, it's an instance of IDER.left, because we use a sealed class as a left side, we can now pattern match again over the left side. So we can decide if it was a not found, we send back a 404, and otherwise we can just log the exception and send back a 500. And now you may think this actually looks quite similar to the try-catch. What did we actually achieve here? Well, to be fair, quite a lot. Because first of all, now because we get an IDER back and we need to return it to a value before we can actually do something with it, before we can actually return it, we are now forced by the compiler to deal with the fact that it can go wrong. So we can't be naive and expect it to be right. We have to make a conscious decision to what happens if something fails. Not only that, because we use a left sealed class for the left value, if we would now add, for example, a duplicate booking to it, in the try-catch world, you don't know this exception got added until someone remembered that was the case. There's no warning for that whatsoever. But the nice thing about pattern matching using when, our code would no longer compile anymore if an extra class is added to the sealed class. You're forced to add it to this when statement. So if any rules change later on, you're forced to think to deal with it. And this might not look much, but actually quite recently, a few days ago, we did a change on a very small service where we converted exceptions into an IDER, and we actually did found a few spots where we forgot to do certain error handling. So it's a very easy mistake to make, and I just love it when I don't have to think about all this stuff, my compiler just does it for me. But although this is really awesome, the actual service becomes a bit more ugly. Because what happens here is, first, we need to get our speaker, but this is an IDER. Then we need to get our conference, but this is an IDER. And to make our actual booking, we don't need IDERs, we need values. So we need to do some quite ugly flat map magic to get the values out of those IDERs, and then store it in the booking. And you can see that it's already not very readable, but the bigger this business logic comes, the more unreadable this becomes. So there's a bit of a dilemma. On one side, I want all the compiler safety that IDERs give me, and on the other side, I want to have readable, preferably imperative code. So I want to have my cake and eat it too. Luckily, Arrow can help us with this. And this is my favorite feature in Arrow, the monad comprehension. So what does it look like? We can just add this block with an either. If we now, within this block, have an either, in this case, I'll just create one, we can now call .bind on it, which means if it was an instance of write, get the value out of it, and in this case, put it in a variable write value. But if it was an instance of left, it would immediately return from this function. So the next line only gets executed if the previous statement went good. So we're back to only having to think into the happy flow. And it will automatically immediately return. It would immediately short circuit if anything went wrong. And we can return in the end. You may notice, however, our function is suddenly suspended. That's because Arrow uses coroutine magic to make all the short circuiting happen. If you're now thinking, yeah, I don't want to put suspend in all my functions, no problem, just use either.eager. And all that stuff gets taken care of you. So if we now use this, what would that do to our service? Oh, very simple. Oh, we just get an either.eager, get our speaker from our speaker repository, call.bind. If everything went correct, this line would get executed. Get our conference, call.bind. We can now just create a booking and store a booking. So we're back to our nice, readable, imperative code, while still underwater doing all this complex flat mapping stuff, but we don't have to think about this stuff anymore. So this is why it's my favorite feature, and I can just add business lines of code and just call.bind on it, and all my error handling still gets fixed, and it's compiler safe, which I think is pretty awesome. So what did we learn? Thanks to eithers, we can get compile time safety, and thanks to the either comprehension, we can still do our old days imperative programming. So that was all about eithers. Kotlin of Arrow also has something other cool to offer, which is called upticks. So immutability is a really good pattern, and I talk a lot about it. I don't have time to explain all the benefits of immutability, so I kind of assume you all want to write immutable applications. And Kotlin actually supports this very well with the Kotlin data class. So there is one problem with it, however. To see that, let's first create some data classes. So you can create a person data class, a city data class, and a street, where a person has a city, and a city has a street, and everything has a name. What if you now want to change the name of the person? Well, in Java, this would be a hassle. You have to create a whole new person object, supply all the parameters and such. Luckily, we have a better language here. We have Kotlin, and we have a data class, so we have a nice copy method. And because we have named arguments, we can just supply it with whatever value needs to be changed. So we can just do a person.copy and supply the new name. And now new person is a copy of the previous person. It just has a new name. This works perfectly fine here. But what if we want to change the street name? Then it starts looking something like this, where we need to get person.copy, change the city property. First, we need to get the city property again from person, so we need person.city.copy, get the street property, then we need to get the person.city.street.copy, and then finally, we can set the street name. So the copy method works really well if you have just a data class. But once we have a deeply nested domain model, this actually doesn't work anymore. If only there was a solution for this. Because I want to have immutability, and I want to have ease of state transitions. So I want to have my cake and eat it too. Thanks to our optics, we can actually do this, because it provides a lens and a traversal. So what is a lens? A lens is an object that's made to look at a certain property of a different object, and look only at that particular property. So if we take back our person, we can create, for example, a lens that goes from person to the city property of that person. So we create a lens, we create a getter, for it, where we get the property we're interested in. And we have a setter, where we can set the property, change the value of that property. So now we have a lens that goes from person to city, and we can use this lens to get the city property from the person, or to modify the city property of a person. Again, this is actually not that interesting, because we could have just used the copy constructor here instead. The power, however, comes when we start creating more lenses. For example, if we also create a lens for the street property, so a lens from city to street, and if we create a lens from the street to the street name, suddenly we can compose these lenses. So we're creating a lens that goes from person to city to street, and from street to street name. So now we have a lens that goes all the way from person to the street name property. And now we can use this lens to instantly change the street name of a person in a deeply nested data structure. If you're now thinking, that actually sounds really cool, but let's be honest, having to write all these lenses is basically more work than actually writing all those copy methods, then you will be completely correct. If you have to do all this work, why bother? Luckily, Arrow can generate this stuff for you. If you had an add optics annotation before your data class, it has to be a data class, it doesn't work on normal classes, unfortunately, and you supply a companion object, Arrow will go through all the properties of the data class and make a lens for that property and put it into the companion object. So if you want to change the street name of a person now, we only have to do this. We can call the person object, get the city lens, go to street, go to name, and now instantly modify our street name property without actually having to write any lenses ourselves. So if you're dealing with deeply nested data structures and having trouble with mutation, this is actually quite a cool thing to use. But only if those are in data classes, unfortunately. Sometimes you just don't want to just change a property in an object. Sometimes a object can also contain a list, and you want to do some deeply nested changes to that list. That's where we have a traversal, where if we have a person object, a new person object, which has a name and another list of persons, of siblings, we can just now create a new object person, Bob, and he has siblings bro and sis. So what if we want to change all the names of all the siblings of this person? Let's first create some lenses. So we create a lens that goes from person to siblings, and we create a lens that goes from a person to name. Now we can start composing again, and within our composition, we can now add a traversal. So we're creating a lens that goes from person to siblings, then from siblings to a traversal over all those siblings, and from then to name. And now in one operation, we can change the names of all our siblings. So if we have lists in deeply nested data structures, we can easily use lenses and compose those lenses to modify all that. If you think, I don't want to modify all my siblings, I just want to modify the first one, we can also just do it by index. So it's exactly the same thing, but instead of traversal, we now use an index. Or we want to change every odd index sibling, we can also just use a filtered index where you can supply a method that selects the index. So what did we learn about optics? Lenses are objects that look at a certain property. We can compose these lenses to create really powerful lenses that can look into properties that are really deeply nested into data structures, and Arrow can generate all this stuff for you so you don't have to. So in the end, I think we can conclude that thanks to Arrow, we can have both a context and an error type as a return type. We can have both compiler support for all our error states and readable code thanks to our IDLE comprehension. And we can have immutability and ease of change. So I think we can safely say that thanks to Arrow, we can have our cake and eat it too. Thank you so much for your attention. I've been Ties van der Ven. If you have any questions, feel free to send me anything on those things. I never post anything on Twitter, but I'll answer questions. Or I'm here now, just come talk to me live so I can talk even more about this stuff. So thank you very much.
Any questions now from the audience? We have about 5 minutes. Oh, there's 2, 3. I'm gonna hit off with someone we haven't heard yet.
Thanks. Yeah, I found this very interesting. I have one question. Since you mentioned you did use it in production, what's your experience with debuggability? Because it adds a lot of things. Is it still nice to like debuggability in sense of actual debugger that you attach? Or
First of all, in practice, I didn't need to debug that much because that's basically the reason I use this. My compiler protects me from things going wrong. Yeah, I could just use debug pointers everywhere.
But it's not, because I mean some of these libraries, you have so many layers of stuff in your stack frames that it gets a bit annoying to step through. That's what I mean.
Yeah, in this case, I did it. I can't even remember if it was more difficult or not. So it might have been slightly more difficult, but just not so much that I got nightmares from it.
Yeah, thanks a lot.
So does the tooling support for the either monad help you not forget to call .bind? Because I feel like that would be something that I would forget frequently.
Yeah, in a way, yeah, if we go quite far back to that example. Yeah, if you don't call .bind, like if you look at my IDE here, so now I have an IDE that I don't call .bind on. If we look at the type of the IDE, it's an IDE there. So if you actually want to use the value that's in it, you're forced to call .bind, or else you should just have an IDE here. So in that sense, you cannot forget to call .bind.
All right, gotcha. Thanks.
Yeah, how do you stay so skinny when you have all that cake?
Unrelated stress.
Yeah, I have a bit maybe a nasty one because I've done this stuff a lot with Scala, where this is very common, and you have even more advanced constructs to deal with it. What I had with Scala is, for instance, when it comes to monad transformers. So you have not only either, but you have another box in a box, which is a different kind of box. So for instance, you have a future, and the future has an either, and then you have to unpack the future. The future has again an either, you have to unpack the either, and then things start to get quite nasty. And as long as it stays in a box, that's fine. But when you start to mix boxes, then things go worse. You have any experience with it, Kotlin? Have you made a bit more advanced examples like that?
Slightly. Arrow offers a few more monads. One of them is validated, and that one just happens to work quite well with either. But that's a bit, basically for us, it's the same problems as in Scala. It's hard to use things like optionals in between. If you start mixing monads, then stuff gets weird. But like an either does have a to-option method, and the arrow optional has a to-either method. So if you mix them, that's going to be difficult, but they do offer methods to transform between the different things. But yeah, if exactly the same as Scala, monad transformers as such make things very, very complicated.
So as long as you stay in arrow, then you're actually fine. They have all these transformations there, but when you
start
to
this
mix,
won't work with a monad from another library, no.
Okay, cool, thanks.
Cool. I think that's it with regards to time then. Thank you so much. Give it up for Thies again. Cool. Our next talk is going to dive into some real-world examples. Not that these have not been real-world, but it's more of a story, and I love storytelling. It's about Greenfield inspiring early on project, so that's going to be a lot of fun. We'll be back in 5.